All right, Math 2, here we go. We got lesson 11.1.2, volume pyramid, day 2. So on the last section, it was kind of an in-class activity where we're just kind of building pyramids and kind of checking out how they look. We talked about how to name the pyramids, that a pyramid's name is based off of its base, like what shape the base is. So if you got a square pyramid, the base is a square. If you got a triangular pyramid, the base is a triangle, so on and so forth. So here we go. Sonia's shopping for a tent and comes across two models that she likes, but she can't decide which one to pick. They're made by the same company, same quality of materials. Tent A is a pup tent, so this is tent A, pup tent. Looks like the floor is a 6-foot square over here. The front and the back are triangles with 5-foot heights. And tent B over here is a tall teepee. The floor is a regular hexagon, diagonal length of 8 feet. Well, that's the height. Okay. What are the names of the two solids? Tent A is not a pyramid because the points don't all meet at one spot. A lot of people think, oh, this is a square pyramid because look, it's meeting up there. No, this side would also have to meet here. This is actually a triangular prism that's laying on its side. And this is a really common error, is for people to call this a square pyramid. Square pyramids would have to meet at one point at the top, and this one does not. So we can tell that this is a triangular prism because I've got a triangle here and another triangle in the back, and then parallel lines connecting those two triangles. That makes it a prism. Whenever you have two bases that are exactly the same connected by parallel lines, that makes it a prism. The other one is a hexagonal pyramid. The base is a hexagon, and then everything is meeting at one point. What tent would you suggest buying and why? So some of you might say, well, it looks like this one has a greater floor space, or I'm going to fit better if I lay down there on that one. And some of you might look at this one and go, oh, I can stand up in this one, whereas this one, my head would be touching the top. I don't like when my head touches the top. So, that's really personal preference at this point. You might talk about the area of the bottom, which one has more area. You might even talk about which one has more volume, how much stuff you can stuff into this one thing. I don't know, personal preference, whatever, we'll move on. Finding the volume of a pyramid. From the day one lesson, we compared a square pyramid to a cube. And we found out by playing around with those shapes that if you compare a pyramid to a cube with the same base, that the pyramid has a ratio of a volume of 1/3 the ratio of the cube. So a pyramid is 1/3 the volume of a prism with the same base area. All right, a student made two pyramids. So these are the same two pyramids. One they made just into a regular pyramid, that we think of. And then one we made as a oblique pyramid. Does the placement of the foam layers change the volume? No, it does not. We have just moved these around so that they're all measured up over here on the side. So where we place the height, whether we place the height right in the middle of the shape to make the height over here, or if we place the height over here on the side, it does not change the height. The height is the same. All we know about the height is the height has to be perpendicular to the base. Where we place the height makes no difference. These volumes are the same because it's the same amount of foam that we're using. So where we place our height does not matter. All right, use pyramid C to test. We already did that on the last lesson. So here we've got this. Yes, we kind of did this already. Sorry, I skipped ahead. Find the volumes of the two tents from the top of this page. Well, tent A is a prism. So the pup tent is a prism. Prisms are base area times the height. So let's look at the base. The base is a triangle. Got a triangle here, triangle there. So the base of the triangle is 6. The height of the triangle is 5. So since it's a triangle, the base area would be 1/2 of 5 times 6. That's the base area. Because it's a triangle, 1/2 base times height. That's the area of the triangle. Now the actual height, the height is over here on this one. The height connects the two bases together. It's perpendicular to the base over there. So the height of this one is 6 over here. So the volume of tent A is 1/2 5 times 6. 5 times 6 is 30. Half of that's 15. And we get 15 times 6, which I think is 90. Yep, it is 90. And that's feet cubed for our units. There's tent A. Tent B. So this one, we're going to say that the volume is 1/3 the base area times the height. Now we do know that this one has a height of 6. It's taller than the other one that only had a height of 5. So we got a height of 6. And it looks like here that the radius that they're giving us is 4. So we need to find out what the area of this hexagon is. So we're getting a radius of 4. Hexagons, remember we take 360, divide by 6 sides, that gives us 60 degrees. The apothem here cuts that in half. Hopefully we all remember that these are 30, 60, 90 triangles. So this is the 2A side, this would be the A side. So if 2A is 4, A is 2, and then this would be the A root 3 side, 2 root 3. So our base area is 1/2 the side length. Well, this side is 2. That means the whole side here would be 4. So 1/2 the side length times the apothem, 2 root 3, times the number of sides. Oops. The number of sides is 6. So 1/2 of 4 is 2. 2 times 2 is 4. 4 times 6 is 24. So the base area is 24 root 3. All right, so the base area of our hexagon is 24 root 3. So our volume is going to be 1/3. Base area is 24 root 3. And we said the height was 6 on this one. Remember, the height is this interior measurement because it has to be perpendicular to that base there. 24 divided by 3 is 8. There you go, sorry. I'm off a little bit here. 24 divided by 3 is 8. 8 times 6 is 48. So we get 48 root 3 feet cubed for that. And if we take out our calculators so that we can compare apples to apples there. So if I do 48 square root of 3, it comes out to about 83.1. So it looks like the pup tent has a slightly bigger volume. So there we go. All right, now we're supposed to fill in a graphic organizer. So, prisms. We said the volume was base area times the height. The surface area in a prism. Remember here we've got a prism. So we said that the surface area was 2 of the base areas plus the areas of all the lateral faces. And we're going to come back to that, I think, eventually and talk about perimeter and stuff like that. But there you go. Cylinders, it was still base area times the height, but in a cylinder, we found out that that was pi r squared for the base area. For the surface area of a cylinder, remember a cylinder, it has two circles for its surface area. So the surface area is 2 circles, pi r squared. And then we cut this apart, and we said that the lateral side turns into a rectangle where it's the height times the circumference, 2 pi r. And now we've gotten to pyramids. The volume is 1/3 the base area times the height. And the surface area is the base area on the bottom and then plus all those lateral areas. And we'll get more into how to devise a better formula for this later. But we do notice here when we compare the prism and the pyramid that a pyramid has one base area because there's only one base on the bottom and they meet at a top point, whereas the surface area of a prism has 2 base areas up there. Interesting thing. All right, that is all the math that we have for you today. Math hard. See you guys later. Bye-bye.